An interpreted language is a programming language for which most of its implementations execute instructions directly, without previously compiling a program into machine language instructions. The interpreter executes the program directly, translating each statement into a sequence of one or more subroutines already compiled into machine code. The terms interpreted language and compiled language are not well defined because, in theory, any programming language can be either interpreted or compiled. In modern programming language implementation, it is increasingly popular for a platform to provide both options. Interpreted languages can also be contrasted with machine languages. Functionally, both execution and interpretation mean the same thing: fetching the next instruction statement from the program and executing it. Although interpreted bytecode is additionally identical to machine code in form and has an assembler representation, the term interpreted is practically reserved for software-processed languages on top of the native processor. In principle, programs in many languages may be compiled or interpreted, emulated or executed natively, so this designation is applied solely based on common implementation practice, rather than representing an essential property of a language. Akin to processor microcoding, many interpreters internally rely on just-in-time compilation. Avoiding compilation, interpreted programs are easier to evolve during both development and execution. On the other hand, since compilation implies translation into more machine-friendly format, interpreted programs run more slowly and less efficiently. This is especially true for higher-level scripting languages, whose statements are complex to analyze compared to machine instruction. Many languages have been implemented using both compilers and interpreters, including BASIC, C, Lisp, Pascal, and Python. Java and C are compiled into bytecode, the virtual machine-friendly interpreted language. Lisp implementations can freely mix interpreted and compiled code. Historical background of interpreted compiled: in the early days of computing, language design was heavily influenced by the decision to use compiling or interpreting as a mode of execution. For example, some compiled languages require that programs must explicitly state the data type of a variable at the time it is declared or first used, while some interpreted languages take advantage of the dynamic aspects of interpreting to make such declarations unnecessary. For example, Smalltalk, which was designed to be interpreted at runtime, allows generic objects to dynamically interact with each other. Initially, interpreted languages were compiled line by line. That is, each line was compiled as it was about to be executed, and if a loop or subroutine caused certain lines to be executed multiple times, they would be recompiled every time. This has become much less common. Most so-called interpreted languages use an intermediate representation, which combines compiling and interpreting. In this case, a compiler may output some form of bytecode or threaded code, which is then executed by a bytecode interpreter. Examples include Java, Python, Ruby. Fourth, the intermediate representation can be compiled once and for all, each time before execution, or each time a change in the source is detected before execution. Advantages of interpreting a language: interpreting a language gives implementations some additional flexibility over compiled implementations. Features that are often easier to implement in interpreters than in compilers include platform independence, reflection and reflective use of the evaluator, dynamic typing, smaller executable program size, dynamic scoping. Disadvantages of interpreted languages: disadvantages of interpreted languages are, without static type checking, which is usually performed by a compiler, programs can be less reliable, because type checking eliminates a class of programming errors. Interpreters can be susceptible to code injection attacks. Slower execution compared to direct native machine code execution on the host CPU. A technique used to improve performance is just-in-time compilation, which converts frequently executed sequences of interpreted instruction to host machine code. JIT is most often combined with compilation to bytecode as in Java. Source code can be read and copied, or more easily reverse-engineered through reflection in applications where intellectual property has a commercial advantage. In some cases encryption can be used to hide source code, or obfuscation employed to obscure its purpose. List of frequently used interpreted languages, APL. A vector-oriented language using an unusual character set, J. An APL variant in which tacit definition provides some of the benefits of compiling. Basic, then basic. ECMAScript, ActionScript function was removed, E4X, JavaScript, script. Equation manipulation and solving systems, GNU Octave, interactive data language, TK Solver, Mathematica, MATLAB. Euphoria interpreted or compiled. Fourth, Game Maker language, Lava, Madness script, Perl, PHP, PostScript, Python, Lisp, Logo, Scheme. Mumps, REXX, Ruby, JRUBY. Seed 7 interpreted or compiled. Smalltalk, Bistro, Dolphin Smalltalk, F-Script, Little Smalltalk, Squeak, Visual Age, VisualWorks. Scripting languages, WebDNA. Spreadsheets, Excel stores formulas, interprets them from a tokenized format. S, R. TCL, XOTCL. VBSCRIPT, PowerShell, XMosaic and XML contain C-like programming language interpreted by a console application written in Visual Basic.NET. Languages usually compile to a bytecode equals. Many interpreted languages are first compiled to bytecode, which is normally interpreted by virtual machine exploiting some just-in-time compilation of bytecode to native code. However, sometimes, bytecode can also be compiled to a native binary using an AOT compiler or executed natively, by hardware processor. Java, Groovy, Join Java, Cold Fusion, Scala. .NET Framework Languages. C++/CLI, C, Visual Basic.NET. Pike, Python, Squeak Smalltalk, Visual Fox Pro, Lisp, AppleScript. See also, List of interpreted languages, compiled language, executable, managed code. References, Brown, P.J. Writing Interactive Compilers and Interpreters, John Wiley, ISBN 0-471-27609-X.